So we will be moving on to our next chapter, and we'll be talking about statistics. Um, statistics. Statistics is one of the most commonly used branches of mathematics in everyday life. And you hear the news, you read the paper, look at magazines, and you see statistics everywhere. And so we are going to spend a little bit of time getting comfortable with some of the vocabulary and some of the formulas and how to use statistics a little bit. Um, Section 14.1 and 14.2 is what I will be covering in this video. And it's very important that you read your textbook to get comfortable. There's a lot of vocabulary in this, and that's mainly what we're going over. And you really need to read those sections, section 14.1 and 14.2, and then watch the video and then read the sections. Either way, they'll help you get more familiar with this material. A lot of vocabulary. So when we are using statistics, we are interested in the population. So it's the collection of individuals or objects about which we are interested in. The individuals can be people, animals, plants, objects, etc. Enumeration is what we're working on right now, and so sometimes one of the things that we're interested in is what is the population size, the size of the population, and that is the n value. So if we're interested in something, in learning something about a population, one way to be figuring out statistics, what we are trying to figure out is statistics is one of the most commonly used branches of mathematics in everyday life of the population. You hear the news, you read the paper, look at magazines, and you see statistics everywhere. And every 10 years, this country does have a census. Going to spend a little bit of time is to collect comfortable with some of the vocabulary, count and every single individual, how to use statistics a little bit, gather other pieces of information. Section 14.1 and 14.2 is what I will be covering in this video. And it's very important that you read. So since that is not always practical, to get comfortable, there's a lot of vocabulary in this, and that's mainly what we're going over. And focus mainly, you really need to read those sections, the concept of a survey and 14.2, and then survey is when you're watch the video and then read the sections. Either way, they'll help you about a population. Get more familiar with this material. You guys are familiar with this, and in everyday life in this class. So when we are, I don't grade every single problem that you do. I would like to know how well you are doing. Collection. So I just take a survey. Individuals or objects about which we are interested in. One of the things that you figure out can be people, animals, plants, objects, etc. Your sample doesn't have to be huge. Enumeration is what we're working on right now, and so sometimes one of the things that we're interested in is accurate description of the population, the size of the population, and that is the n value. So a sample is just a subset of the population. So if we're interested in something, in learning something about a population, one way to figuring out what we are there's different ways of collecting that sample, sampling the data, selecting every member of the population. This is not always practical. You may now when this is 2020 and every 10 years this country does have a create census, a sample. You're going to measure something, collect, count every single individual, a measure that comes from that sample is called a statistic. Gather other pieces of information. Statistic is just a number that describes a sample. From everybody, it's called a census. Draw some inferences about the population from that statistic. So since that is not always practical, is a number that describes the population, typically an unknown quantity. Typically, what we're going to do is we're going to take a sample to tell us something about the concept of a survey population. And so a survey is when you're collecting data from some members, a sample to draw inferences about a population. So you guys are familiar with this, and in everyday life, one sample estimation. I suppose we have a general population of problems that you do. I would like to know how well you are doing to find. So I just take a survey value one problem from each subpopulation. And one of the things that you figure out specific characteristics in this class is, for example, being a defective light bulb. Your sample doesn't have to be huge. We have a general population of known size p, and we want to find the n value of a subpopulation. So what we're going to do that is we're going to choose a sample is just a subset of the population. So in the context, we're going to count the number of individuals in that sample. I pick one problem from each section K. And then we're going to set up the proportion. There's different ways of collecting that sample. Proportion of the active selecting K to N, a sample, number of objects in the sample. Now, when you having that characteristic divided by create a sample, you're going to measure something, and you divided by the how many people measure that comes from that sample is called a roughly be in the same proportion. So statistic is just a number that describes a sample in the general population. Then the population size n divided by the from that statistic. A parameter is a number that describes the population, the total population, unknown quantity. Typically, what we're going to do is only estimate the n value of a subpopulation, the population, a sample, if we know statistics, the size of the general population, to figure out, and many real value of life applications we don't. Okay, so let's one sample we can apply this a very simple problem. Suppose we have a general population of known part of the sixth grade class. We want to find the n brings to value of a jar containing 200 gumballs, having some specific characteristic, gumballs, for example, being the entire population of gumballs. So we have a general population red and of green known size p, and we want Brianna is asked to draw a sample the n value of a subpopulation and estimate the number of red gumballs. What we're going to do that is we're going to choose a sample of size n. Brianna draws a sample count the number of individuals in that sample, of which 14 are red and 26 are green. Use Brianna's sample to set up estimate the number of red gumballs. Proportion of so we want to estimate the number of red gumballs number of in the jar objects in the sample. So going back to our vocabulary of what having that looking at here, divided by the choose a sample of size n. So how many people are in that sample should roughly be in the same proportion. Brianna draws a sample of 40 gumballs in the general population. The population size count n the number of individuals in that sample having the particular characteristic k. And so then what we're looking for is the number of red gumballs. So k is from we can sample, only estimate the red n value of a subpopulation using a sample 14 if we know p, the size of the general population. In many real life applications, we don't. Okay, so let's go over how we can apply this, a very simple problem. And then as part of the sixth grade P, capital P is project the size of the general population, a jar containing 200 gumballs. So this 200 gumballs P is part of the entire population of gumballs. Of two different colors, project, red and green. Brings to class a large jar. Brianna is asked to draw a sample of her own choosing P is 200, and estimate the number of red gumballs in the jar. The size of Brianna the subpopulation draws a sample of 40 gumballs of red gumballs, of which 14 are red and 26 are green. And so then use Brianna's sample to estimate the number of red gumballs. There were 14 red gumballs. Estimate the number of red gumballs in our sample of 40. Should be the same thing as the ratio of red gumballs, which we don't know, looking at here, to the total population. So 200. Choose a sample of size n. And then by just multiplying both sides of this equation by 200, so n in this problem is Brianna draws a sample of 40 gumballs, so n is 40. Count the number of individuals in that sample having the particular characteristic approximation. And again, this is only an approximation. So then what we're looking for is the number of red gumballs divided by 40 is from her sample. How many red gumballs do we have? To be 70. So 14 are red. This worked out very nicely. If it hadn't, we would just round it off. So there's approximately 70 red gumballs out of those 200. Then P, capital P, is the size of the general population. Defective light bulbs. Imagine you are quality control manager from a light part of a sixth manufacturer. The light bulbs come out of the assembly line in batches of 100,000. A large jar containing the manufacturer's specs are that if the batch has more than 2,500, and then what we don't know is 2.5%. The batch cannot be shipped. Subpopulation. You can see here that a lot of the time red gumballs, your ratios are written as percents. And so then the ratio of 14 in this 40, situation, the population of 14 consists of red defective light bulbs in the batch. But testing the entire batch of 100,000 be the same thing as the ratio of red gumballs, which we don't know, too time-consuming in the total population. Instead, 200. You have a sample of 800 selected. And then by just multiplying both sides of this equation by 200, out of the 800 light bulbs tested, 17 turn out to be defective. So since you have a defect rate of 17, we get an approximation. And again, this is only in your sample. You can assume that this is approximately the same thing 14 divided by 40 as the number of defected in your entire works out to be 70 number, which you don't know how many are defective. Worked out very nicely. If it hadn't, 100,000, we would just round it off. And then you can solve this proportion. So there's approximately 70 red gumballs out of those 200. To get that n is equal to 2025. Let's go through another example of defective light bulbs. Imagine you are quality control manager. We can now estimate the total number of defective light bulbs in the batch. Light bulbs come out of the assembly line in batches of 100,000. Approximately the same as the manufacturer's specs are that if the batch has more than 2,500 we have our proportion 17 to 5%. 800 the batch cannot be shipped. You can see here that a lot of the times your ratios 100,000. Solving for n gives an estimate, i.e. a statistic. In this situation, the population of interest consists of the defective light bulbs in the batch, well under the allowed the entire batch of 100,000. To enumerate the defective 2125 is a statistic expensive because it came Instead, you have a sample of 800 selected, a sample and tested. And this is our best guess as to what the population out of the 800 light bulbs tested, 17 turn out to be defective. So since you have a defect rate of 17, finding the exact n value of a large out of 800 population can be extremely difficult. In your sample, you can assume that this is approximately the same is all we really need, as the number of estimates are possible through sampling in your entire the simplest sampling method for estimating the n value of a population is called the recapture method. And then you can solve this proportion. So let's go through how we go about using the recapture method. Step 1, capture. Get a sample. To get that capture, n is equal to sample of size n. Tag, mark, identify the animals, objects, people, and release them back into the general population. We can now estimate the total number of defective light bulbs in the batch. After a certain period of time, proportion of defectives capture a new sample in the entire batch is approximately the same and take an exact head count of the defectives in the sample of the tagged individuals. So we have our proportion 17 to first sample. 800 is approximately n to step 3. Estimate n to 100,000. That the ratio solving for n gives an estimate, i.e. a statistic. K of n is approximately 2125 should be the same defectives in the batch for the well under the allowed quota of 2 populations. So this solve for n 2125 is a statistic round to the nearest whole number because it came from the n value of the population can be estimated by n is approximately. This is our best guess as to what the population just solving size proportion right here, multiplying. Finding the exact n value of a large both sides by population can be extremely difficult and sometimes impossible. In many cases, to memorize this formula, you can just derive that on your own. Such estimates are possible through sampling methods. But notice what everything is here with all these letters. It's for estimating the n value of a population is called the recapture method. So let's go through how we go about using the recapture method. Step 1, capture. Get a sample. Okay, so capture. Again, where did N1 come from? N. Tag, mark, identify the animals, objects, people, and choose and release them back size into the general population. So N1 was the original number after a certain period of time or objects that were tagged. Sample of size N2 and take an exact head count of the tagged individuals. After a certain those that were period of time, capture a new sample size N2 number K. And take an exact head count of the tagged 3, estimate and individuals. Set up the proportion that the ratio of the tag K and the total. So then what you're doing here be the same. You're just comparing. The way I like to remember this all this looks for the 2 populations is and solve for n tagged. If needed, round to the nearest whole number. The n value of the population can be estimated by n1, approximately number of n1 times objects n2 divided by k. Already. Just solving the tagged. This proportion what you don't know multiplying how many are in the entire population. and multiplying both sides by n and estimate by the reciprocal of n2 over k. You don't need to memorize this formula. You can second sample that your second sample size. How many did you collect? Notice what everything is here with all these letters. It's kind of hard to I like remember what everything is. Just tag to total instead of k over n2 is approximately n1 over n. That's just complicated to remember, but tag to total seems pretty simple. Okay, so again, the recapture method two-sample estimation is based on the assumption that both the capture and the recapture size of N1 are representative of the entire population. The original proportion of the tagged individuals in the recapture sample is approximately equal to the proportion of the tagged individuals in the population. Okay. So the tag to total ratio should be the same. A period of time, capture a new sample size N2 and take an exact head count of the tagged. A large jar contains an unknown number of red gumballs. Call this number K. So let me try and keep these, what you're doing here is you're just comparing. The way I like to remember this all this K looks more complicated than it is approximately the same as N1 to total over N. You know that in total, N1, a large jar a large jar tagged already contains an unknown number of red gumballs and 150. What you don't know is how many gumballs. As part of a 7th grade class project, the teacher this is the total. Carlos to estimate the total number of gumballs in the jar using a sample. And 2, okay, so in your second sample, what we're really trying to get at is the total number how many of gumballs, collect. Not of red gumballs, but there you go, gumballs. I like to keep this is what we're going to call tagged to total instead of k over n2 number is approximately n1 over n. That's just complicated to remember, but tag to total seems pretty simple. Okay. The capture-recapture method two-sample estimation is based on the assumption that both the captured and the recaptured samples are representative of the entire population. The proportion of the tagged individuals in the recapture sample is the entire equal to the proportion of the tagged individuals in the population. So the tag to total ratio should be the same. Jar, we know that there are 150 green gumballs. A large jar contains an unknown number of red gumballs. So let me try and keep these k over n2 is approximately n1 over n. A large jar containing an unknown number of red gumballs and 150 is approximately the same as, these will be the tag, n1, this is the total, okay, over n. So Carlos draws a sample of 50, a large jar of gumballs contains an unknown number of red gumballs and 150 green gumballs. As part of a 7th grade class project, the teacher asks Carlos to estimate the total number of gumballs in the jar using a sample. Okay, so what we're really trying to get at is the total number of gumballs, not of red gumballs, but of gumballs. So this is what we're going to call 19 are red. N will equal the number of gumballs, and 31 are green. So I should have been more careful with my labeling. So and 150 green in the jar. So the tagged is which gumballs are green. So N1 is 150. Which is N1 number is in the entire green. In the entire gumballs. And so jar, then that's the total, that there are 100 for the entire population, and K is for your sample. So how many are tagged in your sample? That will be your and in your sample. We're keeping track of the greens, not the reds. Got to be careful with that. I just made a mistake there. So K is 31 green gumballs. A large jar containing an unknown number of red gumballs and 150 green gumballs. So these will be the tagged. This is the total. Okay. And then we can set up our proportion. In our sample, we had 31 green gumballs. 50 gumballs out of. So then Carlos draws a sample of 50 gumballs. Is 50. And this should approximately be the same as in the entire population, of which 19 are red. 50 green gumballs, and we don't know how many. How many are green? So, but we are going to assume that they should be in the same proportion. That's why we're able to set this proportion. We could then find the cross products, cross multiply. We can multiply
and 31
times this one and this one times
so
this one.
I should have been more careful with my labeling.
And then that then gives
and
me
131
green.
So the tagged is which
will
gumballs
equal
are green.
5 times
so
150.
N1 is 150.
50 times
which
150.
is the number
50 times 15. 5 times 15
green
is 75
gumballs.
Do that in my head, and they both have a 0, so we add 2 zeros to it.
And so then,
that's the total, right? That's for the entire population, and K is for your sample. How many are tagged in your sample? 31. And in your sample, we're keeping track of the greens, not the reds. Got to be careful with that. I just made a mistake there. Then N is equal to is 31,500
green gumballs
divided by 31. And the calculator tells me that this is 241. And then we can set up our proportion. In our sample, we had 31 this is only an approximation, so you can round off to wherever makes sense to you. Carlos draws a sample of 50 gumballs. You can round it off to the nearest whole number. That would perfectly be fine. And this should approximately be the same as in the entire population. 240. There are 150 tens place, whatever seems reasonable, because this is just we don't know an approximation. I'll go ahead and round it off to the nearest
how many
whole number. And so we will get 242 how many are green. So, but we are going to assume that they should be in the same proportion. Estimate the number of gumballs in the jar. Set this proportion. And although we did not run through and sometimes this one and this one, collect some animals, tag them, and then release them, and then let them mingle, and then recollect the animal, take another sample, you can see that the same calculations are going into effect. 5 times 150, just looking at the problem in slightly different ways. 50 Again, the important thing to do is to recognize what are your 15 variables, 5 times 15. Right? So N1 was that in my head, the number of green gumballs. That's how many you know are tagged in the entire population. Figure out what N is. N2 divide both sides is the size of the sample by 31, and then K is the so in that sample is equal how many were tagged. 7,500. So both of these ratios divided by 31. The ratios tagged and the calculator tells me, and we're assuming that they are in the same proportion, same ratio. 241.935. Let's see how this is used. So this is only an approximation in some biology. You can round off to wherever it makes sense to you. Stocked with catfish. As part of a research project, whole number that estimate the number of catfish in the pond. 242. Head count is out of the question. 240. Short of draining the pond. To the tens place, whatever seems reasonable, because this is just the capture recapture. I'll go ahead and round it off to the nearest step one number. And for so our first sample, we captured a predetermined number N1 of catfish. Say N1 estimate the number of gumballs in the fish are tagged and released. And although we did not run through and so N1, this is collect some animals of the entire fish population, and then let them mingle. How many and then recollect the animal, so take another sample. You can see that the same calculations are going into effect. Just looking at the problem in slightly different ways. Again, the important thing enough time for the released fish to mingle and disperse throughout the pond. Variables, we capture a second sample, N1 of size was N2. The number of green gumballs of your second sample. You know are tagged in the entire population. And those we can check, and because there's only 200 of them, we can see how many are tagged. The size of the sample is going to equal, and then K, while N2 does not have to equal N1, it's a good idea in that sample, two samples to be of approximately the same order of these ratios. Let's say that N2 is 150 tagged, so we collect 150 total. Of these 150, we can assume that they are in the same proportion, same ratio. Okay, of the 150 catfish in the second sample, used in the field have tags in some biology. So then that's my K. So a large pond is stocked with catfish. As part of a research project, we need to estimate the number of catfish in the pond. Natural head count is out of the question. Ratio of tagged total pond is 21. Best bet to 150. The capture recapture method should approximately be the same thing as the ratio for our first sample. Total, capture the predetermined number N1 of catfish in the entire population. N1 equals 200. We don't know what that is. The fish are tagged, so then cross multiplying again, unharmed, give us 21N in the pond. So N1 is equal to the 2 times the entire fish population, 30. how many are tagged.
But then we have
So
3
there's
zeros
200
to add on to
tagged.
this. And so we have
So then
30,000. And so then when we take the
is 200.
30,000 and
After
divide it by
giving enough
21,
time for the released fish to mingle and
we
disperse
get
throughout the
that
pond,
n is
we
equal
capture a
to
second sample of size N2.
1428.57.
So N2 is the
And
size
again,
of your second
there's
sample.
no point.
What should make
and
sense
those
is
we
to
can
round
check
this either
because there's
to the
only
nearest
200 of them. We
whole
can see how
fish
many
or to the
are
nearest
tagged.
tagged.
So N2
1430 would be fine.
equal,
I'll go ahead and write 1429.
while N2 does not have to equal N1, it's a good idea for the two samples to be of approximately the same order.
Assuming the second sample is
let's say
representative
that
of the
N2 is
catfish
150.
population in the
So we
pond,
collect 150.
the ratio of tagged fish in
of
the
these 150,
second
we can
sample,
easily count to
21
see
to
which ones are
150,
tagged.
is approximately the same as the ratio of the tagged
Of
fish
the 150
in the pond. Catfish in the second sample, 21 have tags. The approximate proportion.
So then that's my K.
Solving for
to
n,
21.
we get 1428.57.
So then,
obviously the value,
which is
n
the number
equals
of
1428.57.
the ratio of tag to
cannot
total
be taken
is
literally
21
since n must be a whole number.
150.
Besides, even in the best cases,
should approximately
computation is only
as
the ratio of
an
tagged
estimate.
to
A sensible
total.
conclusion is that there are approximately
1,400 catfish in the pond.
entire population.
If I don't
and
tell you where to
know what
round,
that
you
is.
can round.
So then
cross multiplying
wherever
again,
you think is
would give us
reasonable, but of
21n. You really could not round to
is
the
equal to
tenth place.
2
That would
times
make
15
sense in the
is
context of
300
this
30.
problem. But the ones
but
place,
then we have 3 zeros
to add on to this tens or the hundredths place.
So we have
30,000. And so then when we take the
Okay,
30,000,
we're done with
and divide it by
section
21,
14.1. Moving on to section 4.14.
we get that n is equal to 1428.57. You hear statistics all the time, and again, there's no point. The statistics,
the numbers that you hear themselves
to the nearest
are
whole
only
part
fish
of the
or to the
problem,
nearest
or
tens.
are only part of the picture.
1430 would be
Sometimes
fine.
what I think
I'll
is
go
even
ahead and
the most
write
important part of the
1429.
picture is how do they come across those numbers. And so in section 14.2, assuming the second sample is representative of the catfish population in the pond, the ratio of tagged fish in the
get a better
second sample, give you a better way to analyze the numbers, is approximately the same as the ratio of the tagged fish in the pond, 200 to
surveys
n.
and sampling.
This gives the practical alternative to a census collecting data from the entire population is to collect data only from some members of the population and use that data to draw conclusions
the value
and make
n
inferences about the entire population.
population.
Literally, since n must be a whole number.
Statisticians call
Besides,
this
even in the
approach
best
a survey
cases
or a poll.
when the
data
computation is
collecting
only
when the data
an
collection
estimate,
is done
a sensible
verbally,
conclusion is that there
asking
are
questions.
approximately
So
1,400 catfish in the
poll,
pond. If I don't
difference
tell you
between a
where to
survey and a
round, you
poll.
can round
Well, a poll is
to wherever
when
you think is
are,
reasonable, but of
asking
course,
questions to collect
you really
your
could
data,
not
your
round
information.
to the tenth
The
place. That
subgroup
would
chosen
make
to
sense
provide
in
the data
context
is
of this
called
problem.
the sample.
But the
and
ones
the act of
place,
selecting
a sample is called
tens
sampling, or the hundredths place would be fine. Surveys and sampling.
Okay, so
Ideally,
we're done
every
with
member of the population should have an opportunity to be chosen as part of the sample, but this is often impossible. Really, you hear statistics all the time, and every time you run some kind of statistics, the numbers that you hear themselves have a target population
only
in
part
mind.
of the problem, or
And,
only part of the
ideally,
picture.
You would
And
want
sometimes
your,
what I think is even
the most important
sample
part of the
to come
picture is
from
how do they come across
the target
those numbers.
population.
And so in section
you would
14.2,
want everybody
to have
we're going to talk about
censuses,
in your
surveys,
sample.
polls, and studies. So this picture
and,
here, where you have the
hopefully
target population, give you a
that's the
better
people that you're
way to
interested
analyze
in-
the numbers that
in,
you were told, finding out information about. But where you're actually going to get your
surveys
information
and
from is
sampling.
called the sampling frame.
practical alternative
And
to a
what you should
census
notice about
collecting
this
data
picture
from the
is that
entire population
not
is to
everybody
collect
in
data
the target
only
population
from some
has
members of the population.
opportunity to be
and
in
use
the
that
sampling
data to
frame.
draw conclusions and make inferences
So the target
about the
population,
entire population.
population for which the survey
Statisticians
applies.
call this
The
approach
sampling
a
frame,
survey
the actual
or a
subset of
poll
the
when the
population
data
from which the
collecting
sample will be
when
drawn.
the data collection is done
So not
verbally,
everybody is going to be
asking
in
questions.
the sample, otherwise it would be
poll,
a census.
difference between a
And
survey
where
and a
you're
poll.
going to get your
Well, a poll
sampling,
is
where you're
when
going to
you
get
are,
your sample from,
asking questions to
is
collect your data, your information.
the sampling frame.
The
So
subgroup
sometimes
chosen
that's
to provide
dictated
the
by
data
how
is
you're
called
going to
the
conduct
sample.
your experiment.
And the act of
If
selecting
you're going to conduct
a
your
sample
experiment
is called
by
sampling.
calling people, then
Surveys and
your
sampling.
sampling frame is leaving out
Ideally,
people
every
who
member
don't
of
have
the
a phone.
population should have an
If you are
opportunity to
going
be
to conduct
chosen
your
as part of the
experiment
sample.
by
but this is often impossible.
sending out emails, then your sampling frame
So
is leaving out people who
every
don't have
time you
email
run some
accounts.
kind of
Experiment,
so that's how that could happen.
you have a target population in mind.
The basic philosophy
And
behind sampling is
ideally,
simple. You
a
would
sample
want
should be
your
representative of the entire population.
sample to come
Right?
from
Everybody agrees
the
to
target
that, but exactly
population,
how you go about
and
that
you would want
isn't
everybody to
obvious.
have an equal chance of being in
Bias,
your sample.
when an advantage or
So
disadvantage
this
is given
picture
to
here, where
some
you have the
portion of
target
the population.
population, that's the people that you're interested
Selection bias.
in
Some members
finding
of the
out
population
information
have no
about.
chance of
But
being included
where you're actually going to
in
get
the
your
sample.
information
So
from is
if
called the
you
sampling
are
frame.
running
And
a
what you should
survey
notice about this picture is that
over
not
the phone,
everybody in the
people who
target
don't have a
population
phone aren't going to be
has
able to
opportunity to be in the
your
sampling frame.
sample.
So the
If you're
target
running
population,
your survey via email,
population
people
for
who
which
don't
the
have an
survey
email account
applies.
are going to
The
have no
sampling
chance of
frame,
being
the
in your
actual
sample.
subset of the population from which the
Sampling
sample will be
bias.
drawn.
Not every member of
So
the
not
population
everybody
has
is
an
going to
equal
be in
chance
the sample,
of being included
otherwise it
in
would be
the
a census.
sample.
And where you're going to get your sampling, where you're going to get your sample from is
Okay, so next
the
we'll talk
sampling
about some
frame.
different types of
So
sampling.
sometimes that's dictated by how you're going to conduct your
One
experiment.
commonly used shortcut
If
in
you're going to
sampling is
conduct
known
your
as
experiment
convenient
by
sampling.
calling
In
people,
convenient sampling, the
then
selection of which
your
individuals
sampling
are
frame is
in the
leaving out
sample
people
is
who don't have a
dictated
phone.
by what is the
If
easiest
you are going to
or
conduct your
cheapest
experiment
for the data
by
collector.
sending
Never mind
out
trying to
emails,
get a
then your
representative
sampling
sample.
frame is
So
leaving out
if you were
people who
wanting
don't
to
have email accounts.
learn something about
So that's how
the
that could happen.
student
The
population
basic
at the Madera
philosophy behind
Center,
sampling is simple.
and
A
you
sample should be
chose
representative of
to
the
go
entire
to the
population.
cafeteria
Right? Everybody
to
agrees
ask
to
people
that, but
questions,
exactly how you go about
that would be convenient
isn't
sampling.
obvious.
Because you're doing it because it's convenient.
Bias.
A lot of people
When
go
an
to the
advantage or disadvantage
cafeteria,
is given to some
but
portion of the
there are
population.
people who are in the population that you're
Selection
interested in.
bias. The
Some members of the
students at the
population have
Madera
no
Center,
chance of being
but
included in
they
the
won't
sample.
have
So
an
if
opportunity
you
to be in
are
your
running a
sample
survey
because
they never go to the
over
cafeteria.
the phone,
They
people who
bring
don't
their
have a
lunch
phone
aren't going to be
from
able
home,
to
or they
be in your
are running
sample.
from, if you're running
School to work and
never
surveyed via
visiting the
email. People who don't
cafeteria.
have an email account are going to have no chance of being in your sample.
Examples: interviewers
Sampling
set up a
bias.
fixed
Not every member of the
location, such as a
population has an
mall or
equal
outside of a
chance
supermarket, and
of
ask
being
passersby
included
to be
in
part
the
of a public
sample.
opinion poll.
So this is convenient sampling. It's convenient, it's easy, but you're going to leave
So
people
next we'll talk
out
about
who
some
don't
different
go to the
types of
mall or don't go
sampling.
to that particular store.
One commonly
Area
used
code
shortcut in
800
sampling is
polls.
known as convenient sampling.
Call
In convenient
1-800
sampling,
UNUTS to
the
give
selection of which
your opinion
individuals
on the
are
new
in the sample
tax
is dictated
proposal by what is the
so
easiest
area
or
code
cheapest
800
for the
polls,
data collector. Never mind trying
it's
to get a
easy. You're
representative
going
sample.
to put up a
So
sign and ask people to
if
call.
you were
But that
wanting
is going to
to
create a lot of bias.
learn something about the
This type of sample
student
is based on
population at the Madera
self-selection.
Center,
It consists of those
and
individuals who
you
volunteer to be
chose
in it.
to
This
go
causes
to
self-selection
the
bias.
cafeteria
Right? So in
to
these
ask
types
people
of
questions,
examples, only people
that
who
would be convenient
generally,
sampling,
not only, but mostly
because
people
you're doing it
who
because it's
generally
convenient. A
feel
lot of people
strongly
go to
about
the
something
cafeteria,
are
but
going to be the ones to
there are
respond.
people
And there's a
who
lot of
who
people
are in the population that you're interested
aren't as
in,
passionate
the
about the
students
particular thing
at the Madera
they're being
Center,
asked to respond
but
about,
who aren't going
they
to
won't
respond.
have
And
an
so
opportunity to be in
this is
your
going to be
sample
biased.
because
Right
they
now, a
never
lot
go
of
to the
students
cafeteria.
run
They bring
to
their lunch
ratemyprofessor.com
from
to
home,
see
or
what
they
people are saying about them. I'm sorry,
are
about
running
the
from
instructor that they're
school
going to
to
take.
work and never
And
visiting the cafeteria.
this type of information is pretty biased because only the people
Examples:
who, or I shouldn't say only, mostly the
set up a
people
fixed
who
location, such as a
are
mall or
really in
outside of a
favor of the
supermarket, and
instructor
ask
or
passersby
really
to be
dislike
part
the
of a
instructor
public
are going to
opinion
report.
poll.
And
So this is
then that
convenient
gives you a
sampling.
very biased view of the instructor.
It's convenient, it's easy,
But
so
you're going to leave
self-selection
people out
bias
who
is
don't
very
go to the
common,
mall or don't go to that
and
particular store.
should be avoided if you want an
Area
accurate
code
picture of what's really
800
going on.
polls. Call 1-800
Convenient
UNUTS
sampling is
to
not
give
always bad.
your
At
opinion
times,
on
there's
the
no other
new
choice, or the
tax
alternatives are
proposal.
so expensive that
So
they have to be
area
ruled out.
code 800
However,
polls.
data collected through
Convenient sampling should always
it's
be
easy.
scrutinized.
You're going to put up a sign and ask people to call.
Next type of sampling we're going to talk about is
create a
quota
lot of
sampling.
bias.
You want your data
This type of
to be
sample
representative
is based
of
on
your
self-selection.
population.
It consists of those individuals who volunteer to be in it. This causes self-selection bias. Right, so in these types of examples,
that
only people who
has a certain
generally,
number of people from
not
certain
only, but
different
mostly people
groups
who generally feel strongly
quota
about
sampling
something
is a systematic effort to force the
are
sample
going to
to
be
be
the ones to
representative of a
respond,
given
and there's a
population
lot of people
through the
who
use of quotas.
aren't as passionate
The
about
sample
the
should
particular thing that
the sample
they're
should
being
have
asked
so
to
many
respond
women,
about,
so many
who
men,
aren't going
so
to
many
respond.
blacks, so many whites,
And so,
so many people
this is
living in
going to be
urban
biased.
areas, so many people living in
Right now, a
rural
lot of
areas,
students
and so on.
run
The
to
proportions in each category in the
see
sample
what people
should
are
be the
saying
same
about them.
as those in the population.
About the instructor that they're going to
The
take.
main problem with quota
And,
sampling is that it is impossible to
type of
account for
information
every
is pretty
statistically
biased
significant
because only the
detail
people who,
and
or I
characteristic.
shouldn't say only, mostly the people who are really in
So,
favor of the
I
instructor
think
or
one of the
really dislike the
agreed
instructor are
upon
going to report. And
methods of sampling
then that gives you a very
tends
biased
to work
view
out
of the
well because
instructor.
it takes out a lot of bias, takes out a lot
So
of
self-selection bias is
human
very
nature.
common,
Is a
and
random sampling
should be avoided.
A random
if you
sampling
want an
method
accurate picture of what's really
uses
going on.
randomness as a part of the design.
So that
Convenient sampling is not always bad.
So
At
that any
times, there's
sample
no other
obtained
choice
is by
where the
chance.
alternatives are so expensive
A
that they
simple
have to be
random
ruled
sample
out.
is the most basic
However,
form
data
of a
collected
random
through
sampling and
convenient
is based
sampling
on the
should always
principle
be
of the lottery.
scrutinized. Any number has an equal chance of being selected from a single set of numbers.
Next type of sampling we're going to talk about is quota sampling. You
So
want your data
here you
to be
have
representative of your population.
sampling space, which
So
is the
quota
sampling
the entire population,
is,
and you're going to pick
when you are
some
going
of those
to
out. Design a sample that has a certain number
the
of
last
people
type
from
of sampling
different
is called
groups.
stratified sampling.
So
And
quota
an
sampling
alternative
is a
to
systematic
simple
effort
random
to force the
sampling.
sample to be
Stratified
representative of a
breaks the
given
sampling frame
population
into
through
categories
the
called
use of
strata.
quotas. A random
The sample
sample is
should
then chosen from
the
these
sample
strata.
should have so many women, so many
Stratified
men,
sampling
so many
is
blacks, so many
typically
whites,
used in public
so many
opinion
people living in
polls.
urban areas,
So many people living in
rural
so you
areas,
break
and
up
so on.
your
The proportions in each category in the sample
should be the same
as those
population
in the
into
population.
different strata, and then
The main
from each
problem
strata
with
you
quota
randomly
sampling
select
is that
people.
it is impossible to account for
And
every
so this is
statistically
different than quota
significant
because you're
detail
not agreeing
and
that you're going to have
characteristic.
certain many of these. You're just making sure that you're going
So
to get
I think one of the
agreed upon
methods of
representative
sampling that
sample
tends
by
to work out well
ensuring
because
that
it
you
takes
have
out a lot of bias, takes out a lot of
people
or
human
elements
nature
from different
is
groups.
a random sampling.
So
A random sampling method
not a fixed number
uses
from each one.
randomness as a part of the design.
So
that
here
in this picture we have a
so that any sample obtained
low-income
is
group,
by chance.
a middle-income group, and a
A
high-income
simple
group.
random sample is the
And
most
we're
basic
gonna
form
take
of
two
a
of the
random
low-income
sampling and is
groups,
based on the
two of
principle
the
of the
three
lottery.
of the middle
Any number has an
group,
equal chance of being
and
selected
two of
from
the
a single set
high-income
of numbers,
and get our data from there.
So in here you have your
Some more
sampling
vocabulary,
space, which is
sampling
going to be the
proportion,
entire population,
percentage
and you're
of the
going to pick
proportion of the
some of those
population
out.
represented by the sample.
Sampling error.
And the
The
last
difference
type of
between a
sampling
parameter
is called
and the
stratified
estimate
sampling,
statistic
and
obtained
an
from a
alternative
sample.
to simple random sampling.
Impossible to
Stratified
tell, but we
sampling
do
breaks
have
the sampling
mathematical
frame into
ways
categories called
of
strata. A
approximating
random
the
sample
error
is then chosen
or
from these
or
strata.
giving bounds for
Stratified sampling is typically
sampling
used in public
variability.
opinion polls.
The natural variability in the statistics obtained by different
So you
samples of
break
same
up
population,
your
even when samples are chosen using the same methodology. Right, so sampling variability
population
means that
into different
not
strata,
every
and then
group
from each
of
strata
10
you randomly select people.
objects is going to
And so
produce
this is
the
different
same
than quota because
results,
you're not
the same
agreeing that you're going to
statistics.
have certain
And
of these.
so that
certain
doesn't
many
mean
of these.
anybody's done
You're
anything
just
wrong. It just
making
means
sure
that there
that
is
you're
going to
going
be
to
some
get a
variability.
you can minimize this variability by taking a bigger sample
representative
size, but there is still going to be
sample
some variability
by
ensuring that you have
so
people.
let's look at number 16
groups
and practice some of our
so
vocabulary here.
Not a fixed number from each one. So here we
An
in
audit
this
is
picture
performed
we
on,
have
on last year's
low-income group,
15,000
a
student
middle-income
aid
group,
packages
and a
given
high-income
out by the
group.
Financial Aid
And
Office.
we're going to take two of
at
the low-income
Tasmania
groups,
State
three of the middle-income group,
Roughly half of the student
and
aid
two of
packages
the
were less than
high-income group,
$1,000,
and
Category 1.
get our
About
data
one
from
fourth
there.
were between 1,000 and 5,000, Category 2, and
Some
another
more
quarter
vocabulary.
were 5,000,
Sampling
were
proportion,
over
the
5,000.
percentage of the proportion of
Category
the
3.
population represented by the
For
sample.
each audit described below, name the
Sampling
sampling
error,
method
the difference between a
that
parameter
best
and
describes it.
the estimate
Choose your answer from the
statistic
following.
obtained from a
A.
sample. simple random sampling.
To tell, but we
B,
do have mathematical ways
sampling.
of
C,
approximating
quota
the
sampling.
error,
D,
or
stratified
bounds for the
sampling. And E, census.
Sampling variability.
The auditor reviews all 15
statistics obtained by different samples of same population, even when samples are chosen using the same methodology.
Census.
Right, so sampling variability
The
means
auditor
that
selects
not
200
every
students, 8 packages
group of 10
category 1,
objects is going to
100
produce the same
8 packages
results,
in category
the same
2,
statistics,
and 100
and
student
so
8
that
packages
doesn't mean anybody's done
in
anything
category
wrong.
3.
It just means that there is going to be some variability. You can minimize this variability by taking a
quota
bigger
sampling,
sample size,
right?
but there is still going to be some
C,
variability.
quota sampling.
Okay, so let's look at number 16 and practice some of our vocabulary here.
Quota sampling is a statistic,
an systematic effort to force the sample population to be representative of a given population through the use of quotas.
Given out
the
by
sample
the
should have
Financial
so
Aid
many
Office
women, so many men, so many blacks, so many
State
whites.
University.
So that's quota sampling, and that's what's going on here.
Roughly half of the student aid packages were less than $1,000. Category 1.
We're going to have
About
200 student aid packages in category 1, 100, 200
and
student
another
aid packages in category 2,
5,000
and
were over 5,000.
student aid packages in category
3.
The auditor reviews the first 500 student aid packages.
Name the sampling method
Student aid packages that
best
comes
describes
across.
it. Choose your answer from the following. A, B, simple random
It's just
sampling.
convenience. There's
B,
no reason behind it. It was
convenient
just
sampling.
easy.
C, quota sampling.
And D, the auditor
D,
first separates the student aid
packages by
sampling,
school, agriculture,
census.
arts, and humanities.
The auditor reviews
engineering,
all
nursing, social
15,000
science,
student
and
aid
mathematics.
packages.
3 of these schools
Whenever you're
are
doing
selected
all,
at random,
that
and
is
further
a census.
subdivided by major. The
10
auditor
majors
selects 200 students,
are randomly
packages
selected
within each
category
selected
1,
school,
100
20
students
packages in category 2,
randomly selected
and
from
100
each of these
student
selected
packages
in category 3.
That would be the stratified. And stratified,
So that's
D,
quota sampling.
right?
Stratified and
C,
quota
quota
kind of
sampling.
sound the same, except there's no in quota. There's no randomness associated with it. We're only guaranteeing to have this many of these and that
Quota
many
sampling
of
is a
those.
statistic,
And stratified, we're going
systematic effort to
break it
force
up
the
into
sample
different
population
groups
to be representative
and
of a given
then
population
choose randomly
through the use
from
of
them.
quotas.
They kind of sound the same.
The sample should have
There's
so many
some subtle
women, so
differences
many
there.
men, so many blacks, so many whites.
So that's quota sampling, and that's what's going on here.
Exercises 17 through 20 refer to the following story.
We're going to
The
have
city of
200 student
Kleinburg
aid packages in
has
category
8,325 registered
voters.
100 student aid
There is
packages
an
in
election
category
for mayor
2
of
and
Kleinburg,
100, and there are
student
3
aid packages
candidates
in
for
category
the
3.
position. Smith,
The
Jones, and
auditor
Brown.
reviews the first
The
500
day before the
student aid
election, a telephone
student
poll of
aid packages
680
that
randomly
he
chosen
comes across,
registered voters
and that's
produced the following results.
it's just
306
convenience.
people
There's no reason
surveyed
behind it. It was
indicate
just
that they
easy.
would vote for Smith.
And
272
the auditor first
272
separates the student aid
indicate that they
packages
would
by
vote
school,
for Jones, and
agriculture,
102
arts,
indicated
and
that they would
humanities,
vote for Brown.
engineering, nursing, social science, and
17.
mathematics.
Describe the
3 of
population
these
for this
schools
survey.
are selected at
Remember,
random.
the population
and
is
further subdivided
who
by
we are
major.
interested in. 10
and
majors are randomly selected within each selected school, and then 20 students
17A
are randomly selected
is
from
the
each of the
registered
selected
voters
majors.
of
And so then that would be the stratified. And stratified D of Kleinburg.
stratified and quota kind of
Right.
sound the same, except there's
And
no
describe the sample
in
for
quota.
this
There's
survey.
no randomness associated with it.
17B,
We're only
what's our
guaranteeing to
sample?
have this many
The
of these and that
680
many of
randomly
those.
chosen registered
And stratified, we're going to break it up into different groups and then choose randomly from them. They kind of sound the same, but there's some subtle differences there. Okay.
Exercises 17
We're
through 20
interested
refer to the
in
following
figuring
story.
out how the
The city of Kleinburg
8,325
has
registered voters
8,325
are going to
registered
vote.
voters. There is an
so
election for mayor of
to
Kleinburg,
figure that out,
and
we
there are
asked
3 candidates
the
for
sample,
the position.
the 680
Jones, and
randomly
Brown.
chosen voters.
The day before the
Registered voters
election,
are the
a
population.
telephone poll of
And the
680
randomly chosen voters
registered voters
are the
produced the following
sample.
results.
Name the
306
sampling
people
method
surveyed
used for
indicate
this
that
survey.
they would
So,
vote for Smith. 272
there is an
272 indicate that they would vote for
the
Jones.
day before the
and 102
election,
indicated
a
that they would
telephone
vote
poll
for Brown. Of 680 randomly chosen. Describe the population for this survey. Produce the following population results. Is who we are interested the election in, and a telephone poll of 680 randomly chosen registered voters. 17. Right. A. So C. Population is the registered voters. I would think that that would be a simple random sample. Of Cleansburg. Right. Describe the sample.
There is some bias in this survey. In that the only way you're going to be part of the sample,
what's our sample,
is if you have a phone.
Randomly chosen.
If you don't have a phone, voters. Then you can't be chosen.
But it does appear to be a simple random. Let's move on to 18. Give the sampling proportion for this survey. We're interested in figuring out how the 8,325 registered voters had 680 people in your sample. And to figure that out, population was 8,325. 680 randomly chosen voters. Sampling proportion voters or the population.
Just this ratio.
680 randomly chosen as voters. % are the
punch that into the calculator. 680 divided
name the
by
sampling method used for this survey.
So as 8.2%.
There is an election the day before the election. A telephone poll
making your
680
with
randomly chosen registered voters.
Of the voters
produce the following results. Give the sampling
for the election,
estimating the percentage of the telephone poll of 680 randomly chosen registered voters, right? From this sample, we get that, I would think that that would be a simple random sample. 306 people would vote for Smith, and there were 680
there is some
people
bias in this, in that
total.
the only way you're going to be part of the sample
divided
is
by 680.
if you have a phone. And if you don't have a phone,
it gives us 45%, but it does appear to be a simple random. Give the sampling.
Let's move on to 18.
Sample statistic estimating the sampling proportion for this survey. 45%. So this came from a sample, so it is a statistic. You had 680 people in your sample. That 45% of the people, entire population, was 8,325. 19. Given that the actual election,
just this ratio, and
Smith received 42% of the vote, Jones 43% of the vote, and Brown 15% of the vote. Find the sampling errors in the survey expressed as percentages.
8.2%.
Okay. So the actual,
you are making your predictions with 8.2% of the votes.
Minus
of the voters.
The give the sampling statistic estimating the percentage
the actual
of the vote to go
minus
to Smith.
The so for Smith, calculated 42
from
minus
this sample,
45.
We get
negative
that
3%.
306 people would vote for Smith, and there were 680 people.
The difference between a
in total.
parameter, so 306
the estimate
divided by
so
680.
Sampling error is the difference between a parameter
gives us 45%
and the estimate.
So the parameter goes first, and so the parameter is what the actual one was, 42%.
Sample
so
statistic estimating the percentage
had an error of negative 3%.
45%. So this came from a sample, so it is a statistic, and so from this we're going to glean that 45% of the people was 43%.
Smith.
19. Given that the actual election, but Smith received 42% of the vote, Jones 43% of the vote, and Brown 15% of the vote.
Jones was actually
43% in the survey expressed as percentages. Okay. So the actual
272 out of 680
minus
should have been 40%. And so they were off by 3%.
The actual
direction there.
Minus,
and then for Brown calculator.
Brown actually got 15% of the vote is negative 3%.
102 divided by 680,
15% of the vote is what the survey said he would receive, and so there was no error there.
The difference between a parameter and the estimate.
No error there.
Right? So sampling error is the difference between a parameter and the estimate.
Do you think the sampling error in this example was due primarily to sampling bias or chance?
So parameter is
Explain
what
your
the actual
answer.
one was, 42%. And so our survey had an error of negative 3%.
Do you think that the sampling error in this example was due primarily to sampling bias?
And so there's some
Jones was
some
43%.
room for error here because we're only going to call people who
but Jones
had a phone. Sometimes people change their phone, and so we would get some error there.
I'm sorry, Jones was
And
actually
there
43%.
is the possibility of chance that we would get a sample
that survey
that was different than the actual population. So I would argue it's a little bit of both. Out of 680. Okay, so here's your homework for this section. This homework will be due next week.
And so they were off by 3%.
And today I will be holding a
and then for Brown
conference to help you
Brown
with last week's
actually
work.
got 15% of the vote.
But 102 divided by 680,
15% of the vote is what the survey said he would receive, and so there was no error there. Do you think the sampling error in this example was due primarily to sampling bias or chance? Explain your answer. Do you think that the sampling error in this example was due primarily to sampling bias?
And so there's some room for error here because we're only going to call people who had a phone. Sometimes people change their phone, and so we would get some error there. And there is the possibility of chance that we would get a sample that was different than the actual population. So I would argue it's a little bit of both. Okay, so here's your homework for this section. This homework will be due next week. And today I will be holding a conference to help you with last week's work.